Good morning, my name is Moji Amini. I represent Hydrogate and Whips, and we are here today for training on sluice gate, slide gates, and weir gates. A lot of this is going to be perhaps redundant, but just use it as a refresher, for the future. One of the first things that I like to go over is the what I call the lingo. It is always nice for the operators and maintenance people to speak the same language as the manufacturer. Because it would be nice if you run into trouble, you need the spare parts, you call the manufacturer, and you don't have to fumble what this nut is called. You can just come up and say, hey, my stem nut, I need a replacement, and I'm just giving you an example. And this is the drawing number, this is the order number, and it'd be very easy. What you do have, in this phase, you have manually operated gates and you have electrically operated gates. Your electric operators are manufactured by EIM, and I know you have a mixture of operators here. You have EIM, you have limit torque, and you have Armor. But going through right from the top, when you get out, when we're going to take a walk, and what you see is from the top, you see a plastic stem cover. And what that plastic stem cover is to keep the dirt and dust away from the grease when the gates are in open position. It's not a great help, obviously, when the gates are closed, because your threads are down below. And also, stem covers are used as an indication of open or closed or halfway. Usually there's a tape on them, and it shows you the what percentage or how much you have opened the gate or closed. Keep them on. It really is a good idea. Sometimes that, maintenance people say, oh, it's really a pain. Every time I want to grease it, I got to take that off and put it on. It really saves the threads on the operating nut, because if you have the grease, this is a very open space, you're going to get wind, blowing wind, and it's going to pick up the sand, and the grease is like a magnet. It's going to get on the grease, and what happens, it gets on the grease, and next time when you open the gate, or close the gate, it's going to bring all that sand and dirt right into the brass nut. And brass nut is specifically designed to be softer than the stem. So it will be like a sandpaper and start wearing your threads. And that's not a good thing, all right? So keep the stem cover on. Again, it could be pain, but I think in the long run, you'll appreciate that you had it on. Next thing would be an electric operator or a manual operator. This here, we call it a pedestal. And then you have the base plate for the pedestal. Hydrogate, if they have a pedestal like this design, they put their name tag right on the pedestal base plate. And there's a sales order right on that tag. And you can also, on the drawing, their sales order is way on the right-hand corner. So when you look at the O&M, when you go through the drawings, there's a sales order, and the sales order is the key to bring the entire file up for discussion. Then the operating stem. Normally there's a stem guide here. This one didn't require it, but there's a stem guide that supports the stem. And then you have what we call guide extensions. There's a nut here, that's the stem nut. There's a brass nut here. And sluice gate, now slide gates with wedge, cast iron, they tend to have wedges. This one has a top wedge, side wedge, and in the bottom doesn't have a wedge, it has a neoprene seal. When it has a neoprene seal, it's called flush bottom gates. When it does have wedges in the bottom, just like the top, they call that a standard gate, standard bottom gate. All right, so that's the difference between the flush bottom and the standard bottom gate. And what we have here, we basically have shown the wedges. These are the side wedges, which are here, and these are the top wedges, right up here. And it would be the same wedge if it wasn't the bottom. And this is the detail of the bottom wedge. bottom seal. These are actually your gates. We took some photos of your gates in this phase. And going through the lingo again, a little better picture here perhaps. Again, plastic stem cover. What you have here is a stop collar. You have the hand wheel. And this doesn't have a pedestal. This is known as self-contained gate, meaning the frame comes up and there's a cross member, and known as self-contained. When it has a pedestal, it tends to be known as a non-self-contained. That's the difference between a self-contained and a non-self-contained. Self-contained is all the thrust is taken by the yoke and the frame. Non-self-contained, you're actually transferring the thrust onto the wall or floor, slab, and so forth. Okay? Stop collar, it must be there on manual operators. That's the only way of preventing overtorque. When I leave here today or the next few weeks, these will be all adjusted. So when you hit the bottom here, you know the gate is closed. You don't have to go any further. It hits it, it stops. However, this stop collar obviously not going to prevent you over-torquing in mid-travel. And that is usually not the case in wastewater treatment plants. That tends to happen more when we have gates on the dams where large debris can lodge itself underneath and the operator goes close. Let's say there was a big log or a big stone lodged itself beneath the gate. The operator, didn't know it was there. And he closes it. He sees they, still got 10 inches of stem to go, but still, is not budging. And instead of going and verifying what's underneath the gate, he goes, gets a cheater bar from his truck, puts it on the hand wheel, and turns it, and the stem becomes oppressive. So we want to make sure to understand, even in your case, if you went and you see still, inches up and the gate is not closing, don't force it. There is a problem. So you need to investigate what the problem is, because it is expensive to replace, stainless steel stem, plus you being out of commission, and it could also damage other parts of the gate. So if you went down and it's not going, and the gate is not cooperating, try to investigate it. Any question there? Again, same picture, except it shows the entire gate, and this one actually is a standard bottom. I can see the wedges here, so there's no rubber seal here. All the four sides will be brass seats, okay? And the way they decide to do that, if the gates are elevated on the wall, they tend to be standard bottom. If they're down bottom in the channel, they tend to be a flush bottom. A little different animal. This one, again, it's a self-contained gate because you can see the yoke, a little short pedestal with an electric operator. And this one is an upward opening gate, but it is a stainless steel, if you want to use the old terminology, is a stainless steel sluice gate. What it does, it has actually wedges. You don't see that very often. It has wedges on the top in order to seal it better. Again, it's fairly uncommon, but they're becoming more and more popular, the stainless steel systems. And when we take a walk, we can talk about it a bit more. But no, it's the same as far as the operation goes. Anything that we can say about cast iron gate, we can say about this. This is your EIM actuator. Again, a little short pedestal we put in here. We tend to not direct mount the electric operator right to the yoke, just because it has conduit entries down here that the electrician likes to use. So usually there's a 10 or 12 inch pedestal here. A bit of a redundancy here, which is, I think is nice. You have a disconnect switch up here, but you also have a disconnect switch on the side here. So you actually have two disconnect switches. Normally you see that if, maybe the main disconnect is way out in the control room, but here they are very close together. So just, be aware that you need to, if you shut this, try to shut that one as well, if you're working on the operator. So we learned about, what the actuator is. Could be electric, could be manual. A lift nut, or which is in the operator, what actually lifts the gate. And there are different terminology for that. A lift nut is the easiest to understand, but it can be also said stand nut. Stem cover we talked about. Limit switches are what's you'll see in the electric operators. The limit switches are basically prevents the over travel. We set just like your garage door opener. You set the limit so when it hits the bottom it closes. When it opens up, it will stop. Torque switches, we will set the torque switches so if there is an obstruction, there is a problem with the gate, actually the gate will stop. It's over torque. Space heaters are inside the operator for condensation purposes. Mechanical dial indicator, there's a white indicator on the EIM actuators. This is the dial indicator right here. And in this case, you have three buttons here. It's a open, close, and stop. And there are lights that are associated with it. A detail of the top and bottom wedge. Once we leave and once we certify that the gate is ready for operation, you shouldn't need to go back and adjust the wedges. The wedges are locked in, they shouldn't loosen. They got a lock nut, same true for the side wedges. And these gates going to be used not very frequently, so the wear on your seat facing is absolutely minimal. So that should not be adjusted. All gates will leak. There isn't a gate out there that doesn't leak. It's not like your valves, like butterfly or plug valves that they're designed to be bubble tight. In the case of a sluice gate, there are limits per AWWA. For cast iron slide gates, the limit is 0.2 GPM per foot of wetted perimeter on an unseating direction, meaning if the flow is behind the gate, pushing the gate away from the wall, and 0.1 GPM per foot of wetted perimeter when it's in seating position, meaning the gate is being forced to seat against its seats. There is, with the cast iron gates, with the wedges, there is what we call a sweet spot. You can make these gates to be absolute zero leakage by just keep torquing the wedges. The problem with that is you will never be able to open it. Same thing with when it has electric operator. If you keep cranking on this, you're going to torque out. You're not going to be able to open it up. It will torque out. So that's why, as long as you meet the leakage requirement and you adjust the torque to achieve that leakage requirement, that should be enough. You shouldn't keep torquing this. And in fact, even in the manual operators, if you try to make these zero leakage, it's just going to be very hard to operate the gate. Again, same wedge, bottom wedge. This is what we call the stem block, stem nut. This is actually located on your slide. There's a nut pocket that stem comes into the gate and attaches to the stem block to lock the obviously stem to the gate in order to lift it. There is a key there, keypad key, and it's going to be hard to see this while it's under the water. But if it is exposed, it'd be nice sometimes to look from the top on your if you doing maintenance, to make sure everything is in place, especially the key, because obviously if the key is not there, the stem could actually rotate. This is inside the operator. This is the lift nut that we were talking, and the lift nut is turned by a hand wheel or electric operator. It has a key. These are all rising stems. So what that means is the stem just comes up without turning. okay? The stem just comes up, the lift nut turns and the stem comes up. Versus a non-rising gate, which the stem is turned and the gate actually crawls up the stem, okay? So if you looking at this in your runs and you see that the stem is actually turning, it's a problem. It needs to be taken care of. It's gonna, if the stem turns on a rising stem, that means it could leave the nut. So that's something to just pay attention. Side wedges, there's a clip here, but you don't have to worry about the clip. That was for the contractor. They put that clip for shipping purposes. So once it's installed, the contractor will remove that shipping clip. Hand wheel, crank, detail of a side wedge. Again, these are adjusted in the factory. We always advise to the contractor, please don't loosen the wedges, don't do anything to the wedges while you install. Don't take it apart. Try to install it as one unit because those wedges are installed in the factory. But we'll go through, just in case, how you need to adjust that. The best way to adjust wedges that I know of is to loosen all wedges. And basically, you loosen the top wedge, the side wedge, and bottom wedge, and then you let the gate come down on its own free way. Just come down and sit nice and square in the bottom. Once you have done that and you know the gate is square, now you'll start adjusting all the wedges. And regardless of how many wedge they are, you can follow this pattern here. You start, and it's, you start 1, 2, 3, 4. Obviously, if it had 4 wedge, then the pattern is like this. If it has more, you just follow that. And once the side is done, then you start from the, top and bottom. And you just follow the numbering system. That just gives you a nice uniform, adjustment of the wedges. And the way I do the wedge adjustment for the sides, once everything loosened and all that, actually I have taken the wedges all up and hand tight so they don't fall. And then once the gate is down, then I loosen the wedge and let those fall. Then I have a brass pin and a hammer, and I'll just go follow the numbering system, but I don't tighten anything up. I'll just hit the brass pin on the wedges, and I go around. And what you like to do is you need to kind of get a feel for it, that you will do it uniformly. So if you start on number 1, you just, let's say you start with 1 tap, then carry it, saying 1 tap here and go up, and then just come around. So don't put your